I'm going to try to illustrate for you how you might estimate numbers of species in a plot. I sized the plot so it fits the screen a little bit better, and I've cheated a little bit, and I've had the program output the number of dots that are in each box. So I have randomly generated a number of dots, and then plotted them sort of evenly through this rectangle. And we'll see that there are different numbers of dots in these different rectangles. I just kind of want to illustrate how you might approach this in the field. In the field, you might not have evenly distributed plants, but this is what I've got for now. If you've got evenly distributed plants, that makes it a lot easier, certainly, but it depends on how many individuals of your species that you're counting are in the plot. And so that's kind of what I want to illustrate here. So let me put up the annotation tool. So what I recommend is you might have a large area that's hard to count everything in. You can get in and start counting individuals, and we want to estimate these. If they're less than 10, obviously that's countable. You should be able to count all individuals. If they're less than 100, say between 10 and 100, you can estimate to the nearest tens. So we're going to do this as kind of a one significant digit estimation. If it's above 100, estimate to the nearest 100, and so on. An exact number would be great, but that's not always feasible, and time is a consideration as well. So let me see if I can just kind of illustrate what I'm thinking about here. So I'm going to connect the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can tell that in an area this size, I've got 10 individuals. And what you might do is kind of estimate how many such sizes you've got in your plot. So I've got 1, 2, 3, 4, 5, 5 circles. Now I'm actually going by the dots and not just by the space taken up. So let's say we found these individuals in the field. We try to kind of draw a circle around how many you think is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So by my current estimation, I'm kind of working up in blocks of tens and multiples of 10. And now I've estimated that about 100 individuals would take up this space here. So 100 individuals, another 100 individuals. It's hard not to be biased. Of course, I can see how many individuals are in here. But it looks like maybe by this method, I would get a number of about 300. So to the nearest 100, maybe not too far off on first estimation there. And that, of course, didn't take us very long. Looks like I have to exit out of this and figure out how to clear my screen. There we go. All right, on to the next one. So I gotta bear with me here. All right, so a smaller number, again, giving us the clue of how many are actually there, but we'll use the same method here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 individuals took up that space, so 10 more, 10 more, and 10 more. I think I lost us for a second. Let's pick that up. So here we are at a plot with an easily countable number of individuals. 1, 2, 3, you can just count those with your eyes. We don't even have to draw on there. So easy enough. All right, here's a pretty good one again. Let's get back in with our pen and annotate. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kind of that size. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I might go to, that's a little too close to the number I can see is the right number. But if I get over 100 and I'm rounding to the nearest hundreds, then this rounds to 100. If you feel comfortable doing a more precise number, you're welcome to do that. I'm going to show you a method here that just tries to save some time on that. All right, another one. That's a pretty similar number. There's a pretty easy number, 2, 8. Here's kind of a big number again. So with these evenly spread spaces, might not be too different to count the same number in different plots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So size of 10 there, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Kind of close, maybe we'll keep going. So 110, 120, 130, 140, 150, 160, 170, 180, 190. So not super close to that number, but again, if we're rounding to the hundreds, then that still gets us close to 200, which was what we would have rounded to anywhere at the nearest hundredth. And you're off. There we go. That's a nice medium number. Annotate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I guess I'm just every time starting with 10 and then kind of establishing a size of how much space 10 individuals would take up of this species in this plot. And in reality, you might choose to do this kind of density circling based on where you find the individuals. So I've kind of left out some spaces here where I wasn't really finding a lot of individuals and drawing circles where they were found. You have to kind of be responsive to heterogeneity in the environment if you're trying to get a good accurate count there. So how many did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, kind of far off. Actual rounded to 70, I would have estimated about 90. I guess I'm kind of emphasizing how quickly you can do this, and you're going to get better accuracy if you take your time. All right, I think that probably has driven the point home. All right, one more. You've been here this long, why not do one more? So this is a number very close to 300. I guess we should be stand a really good chance of getting close to actually estimating 300 based on the fact that that's so close to actual 300. And maybe as we go on, I'm getting more sloppy, and maybe I'm illustrating how that could be a problem. All right, so I got 100 there, another 100 for 200, and then maybe I guess you probably would take this chunk of what's left over and say there's probably still closer to another 100 there. So 1, 2, 300 gets us pretty close to our actual number. So this is what I guess you do in the field using actual plants. So being able to recognize them with your eyes and recognize what individuals belong to each species. And then after kind of getting a visual signal for those, counting them up based on where they are and how densely they grow.